Good morning, everyone. Science Sunday is back. So this week I wanted to do an experiment that was easy, fun with the kids, that you could still eat everything that you used because we're not putting it in water that has vinegar or something kind of gross in it, but also something that will help educate the kids as well. So we're going to use oranges and water to learn about buoyancy and also tie that into life jackets and water safety and why that's so important for the kids. So one of the easiest experiments we've done, in this case I used a vase that I already had at home. I did make sure that the oranges, of course, I used were going to fit inside the vase. Probably a good idea to check that first, y'all. But I have oranges, a vase, and water. Kaylin, that's all. So what I want you to do, Kaylin, is take this orange. I picked one out for you. It's unpeeled. And I want you to gently drop it in the vase, which I already put water in. And see if it sinks or floats. Okay. So what is it doing?
And so far it's floating.
Okay. Is that what you expected it to do?
That is what I expected it to do, but truthfully I got the Cliff Notes on this exercise.
Oh yes, that is true. I guess you did. You did. I did tell you what was going to happen. The other day when I practiced this at home, I put like my entire hand in it and I got water all over my kitchen counter. So what do you think is going to happen? So I'm using the same orange and no one thinks I did anything fancy to it. So once I peel this orange, what do you think is going to happen to it? Again, you have the Cliff Notes,
if I didn't have
if you
Cliff
had
Notes,
not done the Cliff Notes, what would you have thought was going to happen?
I would think that maybe, possibly, it would still kind of hang up at the top for a little bit.
Okay.
Let's see how well it does.
Why would you have thought that? Just in general, like thinking. Because I typically ask a person this, I was asking people this actually in the newsroom the other day. Their reasons why were, well, okay, so the peeled orange, or the unpeeled orange has so much more mass because it has like the big thick like rind on it. But the unpeeled orange doesn't have the mass. So it's all that extra weight and mass. Of course it's going to float to the top while the unpeeled orange is gonna sink to the bottom because it's extra weight. It's like us, we think like we have extra weight, you know, we're gonna weigh more. Well, of course we're gonna go to the bottom.
Right.
So, will we see if that's actually gonna happen? And with that being said, maybe I should have peeled this before. But I wanted to show everybody I was using the same one. Okay, I didn't do anything sketchy to it. I also will say that I was telling my friend the other day when we were talking about this, that it's a good idea too to practice this with the kids with the scientific method, you know, making hypotheses and all that good stuff. Okay, it's unpeeled.
I'm actually really impressed by how fast she unpeeled.
And I actually don't like oranges, so I don't peel these very often. Okay, so same orange. We're gonna drop it in gently. It goes to the bottom.
Straight to the bottom.
Okay, so the reason why, and this is how it ties into life jackets and, you know, water safety and all those things, is that the rind of the orange, which is essentially its skin, it has tiny little air pockets. And so that actually gives it the ability to displace water. Just kind of like how foam life jackets have tiny little air pockets, and it gives people the ability to displace water. We add them to us, it kind of makes us larger. It's the same thing as in, I was running into a pool, jumped in, did a cannonball. You know how when you make yourself tight in a pool, you sink to the bottom? But if you make yourself big and you kind of lay on your back, you kind of float to the top. You're making yourself bigger, giving yourself that lesser density. You're allowing yourself to displace the water. It has to do with buoyancy and also the density. When you have less density, your atoms are lightly packed less tightly. Can't talk today. Whereas when you're really, really dense like that, and it allows all those atoms to be really tightly packed. So this is a tightly packed orange where everything's all sucked in, whereas when it has that nice little rind on the outside, it allows it to have that extra little fluid flexibility where it's got its porous little skin that allows it to float at the top. So hopefully that's a fun little lesson that you can do with the kids on buoyancy. I have a full explanation on our website that I did also print out, so that could allow for a little fun experiment for you to do at the kids at home. You can also print it out for them so they have all their explanations too. So if you don't, as mom and or dad and or parent or guardian, you don't have to sit there and remember everything that I just said.
It's informative and it tastes good. And you know what? Look, we have a few extra oranges in addition to, if you don't want the
That was the thing too. I thought, well, I don't want to encourage people to take their fruit and then ruin it. So yes, you can still put that water in the kitchen sink, pour it out, and still have plenty of opportunities to eat your water or your orange in your water, because it's not like putting it in water is going to ruin it.
Is that like a flavored water situation?
Well, you could drink the flavored water, and then you could also pour it out and still eat the orange, because by putting it in water, all it's doing is giving it a nice little cleanse.
I like that.
Nice little cleanse. We're going to be getting a nice little cleanse later on today because we do have storms back in the forecast, which we will talk a little bit more about coming up right after the break.